Hey, topping our life's math and history, and we are going to take a look at projectile motion. But what we're going to do is solve a problem. So in the past videos, we've been looking a lot about all that stuff over there, with one-dimensional and two-dimensional motion. We've also been looking on how to graph the physics with the distance, acceleration, and the velocity. We've also looked about us talking about some of the properties of a projectile, which is a vertical and a horizontal. And we're going to explain why this is important to our math problem or our physics problem. So when you think of a projectile, the last video we explained that a projectile is something that flies in the air, but is also affected by a gravitational pull. But when it hits the ground, that projectile is no longer considered one, because now it literally hit the ground. So let's move on to the problem. So, in her physics lab, Malini rolls a 10-gram marble down a ramp off the table with a horizontal velocity of 1.2 meters per second. The marble falls in a cup placed 0.51 meters away from the table's edge. How high is the table? So here is what's happening. You roll a marble down the table, but then it falls off the table and lands in a cup 0.51 meters away. And the marble is going off the table at a velocity of 1.2 meters per second. So we can say that's not a straight line. We're trying to find how tall was the table from the ground. So to understand what we are juggling with, we kind of have to understand what the information is given to us. We first said that the marble is a 10-gram object, but since we're talking about projectile, and we're not talking about air resistance, 10 grams is not a necessary piece of information. We do need an information of a velocity of 1.2 meters per second. So we're going to put 1.2 meters per second, and that's going to be our velocity. The marble falls in a cup that is placed 0.51 meters from the table's edge. So we know that away is going to be 0.51 meters away from the table's edge. Not only we need these pieces of information, but we also need a graph to kind of help us understand what we are juggling with as well, visually. So what we are going to do is not actually put graphs and information on the graph or coordinate planes or coordinates. Here's what's going to happen. There are three pieces of information that we need to solve this problem. We have our dx, your distance in the horizontal x-axis, your dy, your distance on the vertical y-axis, and your vx, measuring how fast the object is going on the horizontal x-axis in velocity. So if we have vx, dy, and dx, then we know what we're trying to look for. The problem literally states, how high is the table in the first place? So we know that we need to have information for dx and vx, but we have no idea what our distance of our y-axis is, the height of the table. If you visualize the graph, it's going to go from here and it's going to fall like this. So that is what the marble is going to look like, its trajectory when it goes from the table to the ground. And that is where the cup is, 0.51 meters away. But we still have more information that we kind of have to plug in. We have to talk about the three kinematic equations, and we also have to talk about the speed dating. So we have a table here. When there is a table inside the table, we have a dx, which measures this part right here, the distance on the horizontal x-axis, and your dy, which has a speed dating table inside that table too, which we want to understand because we have no idea what our dy is. the distance on the height of the vertical axis. So, to apply what we know in the past few videos, we understand that if you are free falling, because when you talk about the vertical axis, you free fall only. The AY, or the acceleration, is negative 9.8 meters per second squared. And you use the three kinematic equations to solve it out. So what we know here is our AY is going to equal to negative 9.8 meters per second squared. We also know that if you're free falling, you're literally dropping something. You're not throwing it. So it means that your initial velocity is going to be 0. But there is still a problem with this problem. We only have two numbers of information, your initial velocity and your acceleration. We need at least one more piece of data that will help us understand what to do next. And that piece of data that we are trying to target is our t. How long did the ball go from the top of the table into the cup? Well, here's what the Vx or the dx stands for. We have, for dx, a formula that we can use. Vx is going to equal your dx divided by your tx. This formula can be derived from the horizontal part of it. We use that formula if we say that acceleration for x is going to represent 0. So, if we are trying to find the time in the dy section, but we're also trying to understand the dx section, then here's what's going to happen. From our given, we see that velocity is 1.2 meters per second. So for our Vx, we're going to put 1.2 meters per second on the top so it can help us visualize. Going back to this problem, if we use that formula to find out what t is, we can rearrange it. So if we know that Vx is going to equal dx divided by tx, then that also means we can rearrange it so that tx is going to equal your dx divided that by your Vx. And when we talk about that, we're talking about not x being a variable, the x-axis. That was what we're talking about. So we're saying t is going to equal your distance divided that by your velocity. So our distance is also given to us, 0.51 meters. We're going to put that right here so we can use that for later. But now is later, because if you take a look at this formula right here, we can find out what for t is. So our d divide that by our v. So we're going to have 0.51 divide that by 1.2 meters per second squared. When you get that, your answer for t is going to be 0.425 seconds. That is what we get for t. T is going to equal 0.425 seconds. So now we can move that up to here. 0.425 seconds. But that is just for t. There's one more major step that we gotta do until we solve how high was the table when the marble rolled off the table onto the cup, the plastic cup. How high was the dy, and how high a measurement was the table in the first place. So what we have here is some information that we can observe. Our vi represents 0. Our d, our distance or displacement, is 0.51 meters. Our ay is negative 9.8 meters per second squared, representing gravitational pull. And our t is 0.425 seconds. What can we do? Yes! When we talk about dy, we have to use the three kinematic equations. But which one can we use? We have everything except for Vf. So what we can do to solve this problem out is the second kinematic equation. If you're confused, when we use the dx formula, we get our dx, or our tx, is going to represent 0.425 seconds. We put that into our ty because if you ever knew that tx is going to be the same thing as ty, the reason why is because your dy and your dx is going to be in the same experiment. The marble going down the table into the cup, but you're timing the time it fell and the time it used its velocity. You're using the same time in the same experiment. Just so you know, we put our dy in the wrong thing. That was supposed to be our dx is going to equal 0.51 meters. So going back to the second kinematic equation, the formula is going to equal our dy, or our displacement for y, is going to be your velocity multiplied, your initial velocity, multiply that by your time. Then we have to add that by 1/2 our acceleration. Then we have to multiply it by t squared. And that is a really big formula, but we'll summarize it down. Yes, we gotta simplify it down. What we have is our d is gonna equal 0 times 0.425. However, when we do anything by 0 and multiply it by 0, it becomes a 0. So we can ignore that for now. We have to add that by 1/2 negative 9.8 meters per second squared, because that's our gravitational constant in our gravitational pull. And when you do that, you half it to negative 4.9. When you talk about your t squared, we have to do 0.425 squared. 0.425 squared is going to equal 0.1806. So, since we have a 0, we add that to this, which will not really change anything. But not only that, negative 4.9 times 0.1806. When you multiply these two numbers, you will get your final answer to this problem. So when you do the two answers, you're going to get an answer of your dy, the height of the table, is going to be negative 0.885 meters. The reason why it's a negative is because we're talking about the marble falling to the ground into the plastic paper cup. So that is how we solve the problem, understand the table's height. And that is how we do and understand projectile motion problems for solving the height of something that was thrown or fall. Thank you for watching. I hope this video has helped you understand this video. Thank you for watching Top in Your Life's Math Industry. Like and subscribe.